Hey there, Algebra 2 students. I wanted to go over some questions from section 10.2. And so both the first day and the second day. So we'll start with part A, question 3 or 7 from your textbook. It says you play a game that involves spinning a wheel, and each section of the wheel shown has the same area. Use a sample space to determine whether randomly spinning blue and then green are independent events. My printer is having issues, so this is blue and this is green. Okay, yellow and red. So when they ask you to use a sample space, they want you to list out all of the possibilities, right? So you could spin blue and then yellow, blue and then green, blue and then red, and then blue and then blue, if you're spinning blue first. And then you do that for all of the possible combinations, right? Yellow, 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 green, yellow, red, yellow, blue, green, yellow, green, 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 red, green, blue, red, yellow, red, green, red, 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 blue. Okay. If events are independent, the probability of A and B is equal to the probability of A times the probability of B. And so, right, if they multiply together, it's equal to the probability of A and B, then we know that they're independent. So the probability of blue first, well, that happens 1/4 of the time, right? 4 out of 16 times. What about the probability of green second? That happens in this row here. That's 4 out of 16, so that's 1/4. And the probability of blue first and green second is 1/16. So 1/4 times 1/4 equals 1/16. And yes, there's only 1/16 chance of blue and then green. And so these two multiplied equal this. So yes, they are independent events. Okay. Then we have another spinner. It looks like Wheel of Fortune time. It says you play a game that involves spinning the money wheel shown. You spin the wheel twice, find the probability that you get more than 500 on your first spin, and then go bankrupt on your second spin and round your answer to the nearest tenth. And they have the percent sign here, so you know they want the answer in a percent. So, first we need to count the number of pieces, right, to the spinner. And so I counted them. There are 24 pieces. And so 24 goes in the denominator here for each of my fractions. Well, what's the probability of spinning more than 500 on your first spin? So you go around and you count the pieces that have an amount greater than 500. So 5,000, 650, 750, 950, etc. There are 8 of them total, right? So 8 out of 24. How many pieces are bankrupt? There are 2 out of 24. I want to simplify these before I start dividing. So 8 over 24 is 1/3. 2 24ths is 1/12. And if I multiply those, it's 1/36. When I do that division, I get a decimal, or I can change it to a percent. 2.77, which rounds to 2.8%. 2.8%. Let's see. Suppose that you have a drawer containing 12 white socks and 8 black socks, and you randomly chose one sock and do not replace it. Then you randomly chose another sock. So event A is the first sock is white. Event B, the second sock is white. So to start, you have a total of 20 socks. So that goes in the denominator here. And we're assuming these socks are sort of jumbled and not paired together, right? So you are pulling out, you've got 12 possible white socks. So 12 out of 20 to start. Once that has been chosen, that sock has been chosen, you now have 19 socks to work with. And assuming you chose a white sock to begin with, you only have 11 white socks to work with now. So you multiply the tops together, you multiply the bottoms together, you get 132 over 380. And as a percent, that is 34.7%. And for number 5, it says, at a school, 43% of students attend the homecoming football game. Only 23% of students go to the game and the homecoming dance. What is the probability that a student who attends the football game also attends the dance? Round your answer to the nearest tenth. What is the probability that a student who attends the football game also attends the dance? Okay. So I was thinking of this in terms of probability of A, and B is equal to the probability of A times the probability of B. We know that 43% of students are attending the football game, so that's a 0.43. Right, and then only 23% of students go to the game and the homecoming dance, so that's a 0.23. And so I did 0.43 times x equals 0.23, and I divide both sides by 0.43, and I get 53.5%. Okay, that is it for today. I hope that you are all well. We'll see you next time.